Hello, this is Math106. We are now on week number 2, or I should say module number 2. So for the first part of our discussion, we're going to get to know a few of the terms that we are going to use in Euclidean geometry. 1.1 of your book introduces you to the terms points, lines, and segments. So that's what we're going to learn about. Okay, so let me click on construction tool number 2 and draw a point. Notice that the point here describes an exact location in space. If you look at the algebra view, this point A here, determined by this ordered pair, tells you where it is relative to this whole screen here. So it definitely describes an exact location in space. Let me draw another point here, point P. Again, notice that point P, we don't define points. We simply describe it and say it describes an exact location in space. It is determined by this ordered pair, 9.78 and 2.52. Now, if we draw a line through 2 points, then notice that there's going to be one and only one line that will pass through point AB, 2 points A and B. This illustrates the first basic principle in Euclidean geometry, where it says that through any two distinct points, there is one and only one line that will contain those 2 points. All right, so let's draw another line. If we want to draw another line, so we need to have 2 new points. So let me draw points C and point D here, and then let me draw a line through points C and D. Now notice in this case that this illustrates our second basic principle in Euclidean geometry, where we say that if two different lines intersect, so we have two distinct lines here, then their intersection is a single point. And to get the intersection of those two lines, we go to our construction tool number 2 and choose intersect two objects and click line here, CD, and line AB. And so point E is the intersection of these two lines, CD and AB. Alright, so let me delete line CD because I don't need that at this point. Alright. Now going back to line AB, there are 2 different ways or 3 different ways of naming this line. We either say line AB, or we say line BA, or we simply say line M. Don't forget. So the order in which we name a line does not really matter. They all pertain to one and the same line. Now we define some of the subsets of a line. So let me delete line AB because I don't need that. So one subset of a line involves segment AB, or segment between 2 points. So if I have 2 points, then I can connect both of them by a segment. And here we say this is segment AB or segment BA. Now notice that segment AB is a subset of a line. So if we draw the line through AB, definitely this segment AB is a subset of this line AB. Again, the way we name this line, this segment AB, is either we say segment AB or segment BA. We also define another subset of a line called the ray. Okay, so to name a ray, so we need 2 points. So here if we start from point A and move in the direction of point B, then we are defining ray AB. So here, careful with the order. If you see the notation ray AB, that means to say that it starts from point A and it goes in the direction of point B, which is not the same thing as constructing ray BA. If you construct ray BA, you start from point B and then you move in the direction of point A. So to say that ray AB is the same thing as ray BA is not necessarily correct. So just be careful when you name rays. All right, next one. So let's see. So I need to delete ray AB. Let me delete ray AB for now, and let me draw line AB. And let's get another point on line AB right here. Okay. Now notice that in this case we say that points A, B, and C lie on the same line AP, BC, or AC. In which case we say points A, B, and C are collinear because they lie on the same line. Now if I have a point D that is not on line AB or line BC or line AC, then in this case we say points A, B, C, and D are non-collinear. So we say 3 or more points are collinear if there is a line containing all of them. So in this case, A, B, and C contains a line. Points A, B, and C all lie on the same line. Otherwise, the points are non-collinear. So in this case, we say together A, B, C, and D are non-collinear. Okay. Just a few more things, or two more important things about the section 1.1, and we're pretty much done. So let me delete this. I don't need this one here. Let me clear this, but I need my points. All right. So first we define what is called, or I should say, one property relevant to section 1.1 deals with the notion of collinear measurement. So let me go back and draw my line AB, and let me get another point C right here. All right. Okay, I forgot about that. But this time, let's delete. This time let's measure or draw segments AB and BC. So AB and BC. All right. So and then let's obtain the measures of segments AB and BC. All right. Let's see if I'm going to use this. I'm going to use this construction tool here and measure distance. Distance from A to B, and then distance from B to C. All right, so notice that if I take the sum of the length segment AB and the length of segment BC, notice that the sum of the distances, 4.41 and 3, gives you the total length of segment AC. Let's see if I draw segment AC from here to here. And then if I measure the distance of segment AC and then drag this up here so that you see, wait, not this one. So I need to measure the distance of segment AC right here. Okay, and then drag this right here, up here. Notice that if you measure the distance of segment AB and BC, it actually gives you the sum or the distance or the length of segment AC, which is 7.41. So this is our first length measurement fact. We say lengths along a line add together. All right. Okay, so let me delete a few other things that I don't need. I don't need this anymore. All right, I don't need, so let me delete this line here. All right, now next we deal with what is called the non-collinear measurement. So notice that in this case, we have A, B, and D are non-collinear points, but let me get rid of this AB. And let me measure the segments first. So let's construct our segments, AB, BD, and AD. All right. And then let's obtain the measure of their sides. So this is segment AB and segment BD and then segment AD. Alright, so let me drag this just right here and here so that you see. Now, if this time you have three non-collinear points, in this case, these three non-collinear points determine a triangle. In fact, a triangle, one way of describing a triangle is that it's determined by three non-collinear points. Then we say the length of the longest side is less than the total length of the other two sides. So this is the length of our longest side, AB, which is 4.41. Notice that it's shorter, or it's actually less than the total length of the two other sides, 3.34 and 2.97. So let me obtain the measure of those two other points here. So we say distance AD, okay, so DA plus BD. So notice that it's 6.3. See, look at that. So the length of the longest side here, which is supposed to be segment AB, 4.41, is actually smaller than the length of the two other sides. Now, if you change it just a bit, like this, see, and keep this segment AB as our longest side, no matter what happens, notice, look at the numbers here. No matter what happens, the longest side will always be smaller than the sum of the two other sides, as long as you keep this as your longest side. So that illustrates the non-collinear measurement fact that in any triangle, the length of the longest side is less than the total length of the other two sides.